Hello to everyone. I am Meghna Sharma is going to teach you in grade 8 Maths Chapter 1 Rational Numbers, and today I will teach you the main new terms of the chapter. The first one is natural numbers. Natural numbers are a part of the number system which includes all the positive integers from 1 to infinity. The most important thing note is natural numbers do not include negative numbers or 0. It starts from 1 and till infinity it ends. Next is whole numbers. Whole numbers are the basic counting numbers. It starts from 0 till infinity, like 0, 1, 2, 3, 4, 5, 6, and so on. Suppose there is a hole in any fabric, which number it represents? 0. So 0 as a whole number represents nothing, or its value is null, but it starts from 0. Next is integers. Integers are the number which can be positive, negative, or 0. Yes, for example, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. It means all positive and negative numbers include 0 are called integers. These numbers are used to perform various arithmetic operations like addition, subtraction, multiplication, and division. The main chapter name is rational numbers. What is that? A rational number is a number that can be expressed in the form of P upon Q, where Q is not equals to 0. Q is the denominator and P is the numerator. In P, we can write 0. But in Q, if we are writing 0 in the denominator, it cannot be a rational number. For example, you can see 0.3. When I am writing 0.3 in the form of fraction, what it comes? 3 upon 10. Yes, it is a rational number. When I am writing 5, it means its denominator is 1. So it is also a rational number. When I am writing 7 upon 9, yes, it is also a kind of a rational number. When I am writing 0 upon 2, yes, that is also a rational number because here in the denominator is 2. When I am writing 2 upon 0, it cannot be a rational number because a rational number is a number that can be expressed in the form of P upon Q, where Q is not equals to 0. The next is additive inverse. An additive inverse of a number is defined as the value which on adding with the original number results in 0 value. It is the value we add to a number to yield 0. Yes, additive inverse words come from addition. The opposite of addition will be subtraction and the subtraction will become addition. For example, additive inverse of 10 is -10. When we are adding both of them, it will become 0. See, 10 plus -10 is equals to 0. The additive inverse of -9 is 9. So when I am adding both of them, it will become 0. -9 plus 9 is equals to 0. Yes, the next is multiplicative inverse. The another name of multiplicative inverse is reciprocal. Reciprocal is simply defined as the inverse of a value of a number. If n is a real number, then its reciprocal will be 1 upon n. I am giving you the example. 2 is a number. When I am writing its reciprocal, it's 1 upon 2. When I am writing 7 upon 9. So the multiplicative inverse of 7 upon 9 is 9 upon 7. Thus, here we convert the number into an upside down form. Numerator will become denominator and denominator will become numerator. For example, the reciprocal of 9 is 1 divided by 9, that is 1 upon 9. When we multiply a number by its reciprocal, it's give a value equal to 1. Suppose I am giving here example a upon b. What is the reciprocal or multiplicative inverse of a upon b? That is b upon a. And I am multiplying both of them. What it comes? 1. Thus, it is also called multiplicative inverse. Next, the properties of rational numbers. The first is closure, second is associative, third is commutative, and the fourth one is distributive property of multiplication over addition and subtraction. First is closure property. Yes, when I am adding two rational numbers, the answer will be a rational number. Yes, it is applicable in closure property. Subtraction, yes, it is also applicable in subtraction, because when I am subtracting two rational number, what the answer it comes, it is also a rational number. In multiplication, yes, it is also applicable. When I am multiplying two rational numbers, the answer will become a rational number. Here examples are also given for you. For division, a divided by 0 is not defined so, because denominator is 0. So rational numbers are closed under division also when only c upon d here is not equals to 0. The set of all non-zero rational number is closed under division. When I am dividing two rational numbers, the answer will become a rational number. Next is associative property. Yes, it is only applicable in addition and multiplication, because they are having two hands, LHS and RHS. When I am multiplying three rational numbers together in a different forms, both LHS and RHS will be equal. When I am multiplying it, yes, it is equal, but in subtraction, it is not equal, and in division also, it is not equal. You can take the example of addition while putting the value a upon b is minus 2 upon 3, c upon d is 3 upon 5, and e upon f is minus 5 upon 6. Same like that, you can put in the subtraction, multiplication and division also. You can check by yourself also. Associative property is only applicable in addition and multiplication, because in that LHS is equals to RHS. Next is commutative. Yes, in this property also only it is applicable in addition and multiplication. Same like that, it has two hands, and when we are adding both of them, LHS and RHS, answer will be the same. Same with the multiplication, but not applicable in subtraction and division. The next is distributive property of multiplication over addition and subtraction. Yes, when I am adding a upon b, I have taken out as a common c upon d plus e upon f. When I am multiplying a upon b into c upon d, then plus sign will come in between, and then a upon b is multiplying by e upon f. Yes, this is called distributive property of multiplication over addition. In subtraction, in bracket there is a subtraction sign, so that property is called distributive property of multiplication over subtraction. Whatever the sign is in the bracket, we put distributive property of multiplication over subtraction or addition. Existence of identity, that's the important thing. 0 is the additive identity. When I am adding anything with the 0, what it comes? The number itself. Suppose I am taking here an example. A upon b plus 0 is equals to 0 plus a upon b. What it comes? A upon b. Suppose I am adding 2 upon 3 with adding 2 upon 3 plus 0. What it comes? 2 upon 3. So that is called additive identity. And 1 is the multiplicative identity. When I am multiplying any number with the 1, what it comes? The number itself. So here you can see a upon b. When I am multiplying by 1, what it comes? A upon b. So that is called existence of identity. Yes, existence of inverse. What I have told you additive inverse and multiplicative inverse. Additive inverse, what it comes, addition will become subtraction and subtraction will become addition, vice versa of it. You can see minus a upon b is the additive inverse of a upon b, and a upon b is the additive inverse of minus a upon b. So when I am adding both of them, a upon b plus minus a upon b, that is equals to 0. And when I am adding minus a upon b plus a upon b, that is also equals to 0. So that's why it is the additive inverse. Next one is multiplicative inverse. I have told you, as the another name of multiplicative inverse is reciprocal. It means numerator will become denominator and denominator will become numerator. So when I am saying a upon b into c upon d is equals to 0, so I can check c upon d into a upon b is also 1. So where c upon d is the reciprocal of a upon b. 0 has no reciprocal, and the reciprocal of 1 and minus 1 is the same. 1 and minus 1 has its own reciprocal. Thank you everyone. I hope you will understand this chapter very nicely. Thank you.